Happy Memorial Day to everyone. I'd originally planned to do some kind of electrical demonstrations, but it's very muggy today, and electrical demonstrations work better when you can generate some static electricity. There's a little too much moisture in the air. So today I thought we would talk about magnetism. Most of us are familiar with magnets. I have a simple bar magnet here, marked with the north and the south pole. I also have a small, fairly strong horseshoe magnet. Again, one pole will be north and one pole will be south. And I have a couple of ceramic magnets that like to cling together. And most of us know that like poles of magnets repel each other. So when I try to bring a north towards the north, it repels. If I try to bring a south towards the south, it repels. But north and south like each other. Not everything is capable of being magnetized. Most bits of iron are. In fact, people may not know this, but the Greeks used to mine iron from a place in northern Turkey called Magnesia, and that's where the name magnet comes from. Aluminum, as you may know, is non-magnetic, and regardless of how strong the magnet might be, the aluminum doesn't respond to it at all, but any piece of metal will. Now, interestingly enough, it is possible to explain why things become magnetic. And although it's not obvious, it's because magnetism is created by moving charge. And we can show that they're related. I have over here a couple of little bars of iron. They're not magnetic, and as you can see, they're just hanging next to each other. But I have them inside of a large coil. When I run electricity through the coil creates a magnetic field. And that magnetic field will actually magnetize these two iron bars. And because, again, likes repel each other, just like that. These don't like each other when they're the same side. These are both going to be magnetized the same way, and so they'll repel. So I have this connected to a power supply. I'm going to turn up some electrical current, and as you can probably see, those two bars are now pushed away from each other for no reason other than the fact that this coil is creating a magnetic field. If I turn the current off, those two bars will go back together. I can demonstrate that this coil is actually producing a magnetic field in another way. This is a small ceramic magnet, which I'm just going to place inside this coil. We call it a solenoid. And I'll turn the magnetic field up. And now, looks like I'll need a little bit stronger current. So let me get a slightly larger electrical current. There we go. And now, maybe I have it the wrong way. There we go. It's actually levitating inside of this coil. If I look down in it, I can see the ceramic magnet floating. And again, I'll try to pick it up here. I can give a little more current, I think. That's the wrong way. As soon as I cut the electrical current, the magnet will fall out. So that's a little touch of magnetism for today. And next time I'll show you a few more little tricks that we can do with magnetism.